I don't know how good this is going to work, but heck, I figured tinkering with something, set the camera up. Haven't done a video in ages. This is a push-pull tube power amplifier. It is a, for those who know, it is basically a Dynaco ST70 that has the vacuum tube audio driver board with the octal tubes upside down. This one is unusual in that it has all toroid transformers except for this choke. This one's for the bias. This is 5-volt filament to run the rectifier. This is B plus and 6.3 volt for the other filaments. Let's see here. It has toroid output transformers. It's a nice looking amplifier. But the guy who owns it has, when I had this once before to fix some other issues that was just missed, that the speaker terminals were not labeled. The wiring didn't match the labels. Anyway, that's easy. It was easy to fix. Everything else worked fine. It's really nicely put together. It had an issue where some of the filament wires were twisted and some weren't, so I took care of that just to lower the noise a little. And it biased up fine with the tubes he had, which were KT66s. But he says it will not bias up with EL34s. He's tried 2 different sets, and so my guess is that the negative bias voltage won't go low enough, so you can only get about 200 milliamps or 20 milliamps out of them, and not the 40 that he's looking for. So got some little feet so I can put it up on the air and work on it while it's got tubes in it. So we'll stick 2 more of those on there, which is what I was doing when I decided to turn the camera on. These are just pieces of Baltic birch plywood that got a hole in the end, and they're like 6 inches long. So should be, you know, what, 150 millimeter, something like that. So just stick these in real quick. Get it lined up. Nothing fancy. So what we're going to do is, to start with, just measure the bias voltage at both ends of the pot range and see what we get with no power tubes and no tubes at all, including the rectifier, so there won't be any extra high voltage on the caps without the load. So, my elbow is probably right in the camera, but that's okay. Okay. Center this up a little bit so don't fall over. Okay. So I think that's in the shot, but so we'll set that on DC volts. And let's see. Set it to ground. And we've got our biases outputs on all 4 of these caps, so we'll just take this one to start with. And the adjustment pots are right here and right here, which I know you can't see very well. So you can get a screwdriver. Will that fit under there? Nope, too tall. Okay, this should work. Make sure it'll fit in there. Yep. Alright, I'll hook up some power. Obviously being careful now that it's got juice to it. Okay, we have right at 42 volts. And it should be negative. It is. Let's see what our range is on this. If I can get it in the slot on the bottom. Maybe the screwdriver's too big. Goes in the hole, won't go into the slot. So, we'll find something else real quick. So, we've got it's a little screwdriver. It used to be for cartridges, I think. I stuck a piece of tape and heat shrink on it because just in case these pots are a little wonky. Although the chassis is grounded and it's going to touch that, so well, if it would fit in there. There we go. So the lowest, yeah, all the way maxed out, the lowest voltage I can get is 39.5. And if I go the other direction, yeah, almost 77 volts of negative bias. So we've got to figure out what the, I mean, I've got the schematic, but it was, I think, originally designed for, I think it said 65 volts in the schematic, and then so it's got dropping resistors for that, but maybe it's got the wrong ones in it, maybe it's higher. So what we need to do is measure our bias voltage coming off of the diode, which I think is right here. Yeah, so we've got 80.5 volts, 80.6, whatever, 80 volts. And so we got to figure out what our resistor is for that, and then do a little math and change out some parts. Probably only have to change one resistor. Just got to find it. My guess is we can turn this way and get rid of the power. My guess is it's that resistor right there, because this is the AC input from the bias transformer. The reverse connected diode, so measuring right here we get negative 80.5. There's its smoothing cap. So my guess is that that is the resistor, which is supposed to be 39K, and I can't see it good enough to tell you what the value is without some more light and magnification, because I'm old. That does not look right. That looks like a 1K or 10. Let's see. Make sure I ain't got any voltage across it. Nope. Let's see what we have. Looks like brown, black, black, brown. Yeah. Yeah, 1K. I don't know if that's the right resistor, because of course they're not labeled on here. But the schematic shows 39K, if that's the right resistor. And looking at the traces, which I know you can't see, it looks to me, yeah, that has to be it. Because there's the diode, the cap, and then this resistor, and nothing else is connected to it. Let's measure the voltage on that resistor and see what we get. I'm going to guess we're going to get our 80 volts. Let's put the power back to it. Okay, we're live. So if we measure the voltage on the one side of the resistor, whoops, it's on ohms, so flute probably didn't care. Sure enough, there's our 81 volts. 80.5. 78 on the other side. Yeah, that's the problem. Schematic shows 39K. It's 1K. And, you know, that ain't going to get it. So, the good part is, I think, unless he folded the leads over, I can probably get it out without having to take the board out. So, let me hunt up a resistor. Let's see, 39K. 33K 1 watt. We don't need nothing that big. Are these 39s? Orange, white, orange. Well, it should be 39K, is that right? Where's my brain damaged? can't always remember the color code. 39K. Cool. So we got a resistor, and we 99% chance that this will take care of it. So, okay. Not sure how this will turn out, but it looks like it's in frame. So I got a little solder wick. What we're going to try to do is make sure I'm unplugged, which I'm not. That would be stupid. We're going to extract this little guy right here. I'm going to check, make sure there's no voltage in the area. I don't think there will be, but it never hurts to check. Okay, we got none. Well, of course, there won't be any on that side. There can't be. Nothing on these caps. Nothing on the B+. So, what's on this side? It's the 20 millivolts. Nothing anywhere to worry about. Okay, so we're good. We're safe. Now, a tricky bit. Hoping that he didn't fold the leads down over, and I can heat these up enough to get it out without having to take this board out of here, which would be really good. Oh yeah. There's one. Okay. There's two. Alright, so there's our offending resistor. And we'll take a little bit of wick and clean up the pads. Shouldn't take much. That one's good. Get on there. Is that one clean? Get some more light. Nope, not quite. Let me put a drop of solder on it, because that'll make it easier to wick off. Trim our wick. Okay. Let's try this with a little bit of solder on it and some fresh wick. Get in here without melting anything. It does not want to come clean. I think I might have got it. Let's see if our resistor will go in. Yeah, we're good. Okay. I just used some needle nose to bend it over, and that's a pretty good match. So this guy, I better cut the leads first. That won't work. Okay. All right. Try to keep my hands out of there so you can see. Not that there's a lot to see, but that side's in. Just kind of guide this in a little bit. We should be pretty much good to go. go. That's in. Really use a little more light on this. If I can get this in here without blocking the view. Yeah, that's good. Didn't look like it didn't change the picture much, but I can see worlds better. Alright. So let's tin or iron. Alright. Okay. Sorry if my head's in the way, but I have to be able to see this. Okay. I think we're good. Okay. That looks good. Let's get our voltmeter here. And I will zoom you out a little bit. Other way. Looks like the voltmeter's in the shot, so let's clip this guy to ground. And hook the power back up. Get rid of the solder wick. Okay, power on. So now we have 32 volts on the other side of that resistor, which may not be enough. We actually should have about, I'd like about 50. So we may have to go somewhere in between, because this side we have 81, this side we have 33, but that's what those pots adjusted all the way to one end, which will tend to shunt some of that out. So let's see about turning them the other way. About halfway. Our output voltage now is 22 there, and whoa, that could have ended badly. So we still only have 33 there, and I don't think that's going to cut it. Really want about 45 to 50. So I'm going to do the math and figure out what the, well, let's just figure it out. Let's see. We're dropping, we got 81.5 and we've got 33. So we'll do the math real quick. Let's see here. We got 81.5 minus 33, so we're dropping 48.5 volts across 1K. So that gives us, let's see, divided by 1,000. So we're dropping basically 50 milliamps. So 50 milliamps, and we only want to drop 30 volts. Or no, that's not 1K, it's 39K. Duh. What did I say? 81.5, 33. So yeah, we got 48.5 divided by 39,000. So that is 1.2 milliamps, 1.24, blah blah blah. Doesn't matter. 1.2 milliamps. So if we want to keep the current the same and change the voltage. Think about it. R divided. So, say we want to drop, instead of dropping 40 volts, say we want to drop 30. So 30 volts divided by 0.00124 would be 24K at the same current. So we're going to play this again. We're going to change it to a 24K and see what we get, because that isn't going to be enough bias. I really want at least 45 or 50 volts. So let me hunt up another resistor and change it. I will not make you watch all that. Okay, slight change of plan. Before I change it out, I'm just going to experimentally clip another 39K in parallel, which is going to give us roughly 19.5. See if that works out right. It should, but hey, you know, it might not. But it's a lot easier than unsoldering it and putting the wrong one in. So of course, I guess I could just take and put a pot across here and adjust it till I get what I want and then measure everything, but this will work. Yeah. Okay. So let's hook our power back up. Kind of a pain in the ass location. It's in the back, which I guess makes sense, but it's a pain to work on. Okay, we should be juiced up. And we just lost our ground. Everything is going well here. Yeesh, there's got to be a better place for this. Let's try this side. Oh yeah, that's much better. Alright, so the output of our bias is, turn the meter on, it'll work better. Can you see that? Yeah. So now we've got 36 at that with the pot somewhere in the middle. And our voltage on that is, there's our 82, and on this side we have 47. Is that right? Yeah, 47. So that's with about 20K, 19.5, something like that. Like a little bit more. So I am gonna change it, but I'm just gonna go for a let's see. Nearest standard value is either 22 or 27K. Should have some 22s in here. I do. I'm going to swap that out for 22K and I'll bring you back and we'll check it out. Okay, we're back. That only took a couple minutes. It's a lot easier with, I didn't have to work around the camera. I could stick my head in there. So, I'll hook the power back up. Alright. Put this on volts. Turn it on. And our voltage here is now nothing. 44.5, which should be pretty good. 34 volts on the lead going to the power tube. Let's see what our range is now. So we can go from 22.8 all the way to 44, which should be adequate because they were at about 40 before. That should be good for most any tube he wants to run. So I think what we'll do is turn this off, obviously. Let's turn it over, put some tubes in it, and try to bias it up and see what happens. I'll bring you right back. I just got to take the legs off, and I don't even know if I got to take the legs off. Well, let's just try this. Hang on. I don't know if you can see this. So the chassis for this just has a solid wood bottom, so you can't take it off to work on it. So the screws are in there, but it should. Just let me flip it over here. So get this spun around without wiping out everything on the bench. Put our dummy loads on. Just stick those on there. And I gotta go find the power tubes. 5962. So these takes 3 6S and 7s. And pentodes, there should be EL34s, KT66s, 6V6s, pretty much what have you, assuming the bias is set right. And a 5AR4 goes in there, which I should have here. Get it out of the box. Just open the wrong end. So that's always what happens. Okay, but before we stick the 5AR4 in there, I want to make sure that the bias pots are turned in the right direction. I'm going to assume, but I could be wrong, I'm going to assume that counterclockwise is the most negative, so that we will underbias the tubes to start with. We're going to measure it and see with no high voltage. And I don't know the pinout by heart, but we'll look. And it looks like over here. Okay. So put our meter on. Let's find us a ground. I'll just stick it on one of these resistors. They're hooked to ground, right? And some power. And indeed, negative 42 volts, and it's all the way counterclockwise. That's good. Let's check the others while we're at it. 44, 44, 44. Okay. We got negative bias everywhere. Now I don't have to worry. So, these are actually some really cool looking tubes. Chinese Shugong. Super Tube for Music Fanatics, which I thought was a really cool name. Beautiful boxes, really cool looking too. The only downside, well, maybe there's more than one downside, but and he told me about this so I wouldn't have an issue. I have not tested these, but these are the 6S and 7s, and these are the 6CA7/EL34s. Obviously, they use the same envelope. I mean, it's real easy to see that that's a little double triode and that this is a pentode. But still, if you weren't paying attention, you could potentially stick the triode. You know, you could put them in the wrong sockets, and that would be bad. So there's that. This is one of the 6S and 7s. Where is our key? Right there. So this guy goes this direction. And this guy goes here. Okay. There's that dude. And there's that dude. Okay, we'll put our rectifier in, and let's power this up, and we're going to put this meter on the, okay, So the way this is set up is it's got a 10 ohm cathode resistor, and it measures, measuring on these, it's measuring across that 10 ohm resistor, so that if you read 400 millivolts or 0.4 volts, it's going to be 40 milliamps. So, and then that's what he was looking for. And so we've got this on one of them. As soon as they warm up, if this goes above, it should be in the shot. If it goes above 0.4, then of course we're going to turn it off instantly, because they are as much negative bias as they can be right now. So we are drawing 75 watts, 0.6 amps. I'm assuming as soon as the heaters warm up, it's going to start drawing current. It's going to go up, and there we are, 90 watts. And our bias on this is 0.07, so 7 milliamps. It's drawing 0.8 amps, 95 watts. The tubes are all glowing. It's a pretty good sign. Now let's try very carefully turning the bias up on this one. See what we get. Oh yeah, look at there, no problem. There's 20, 30, 44. So let's just set them at 30 to get them all close, because they'll interact with each other, and then we'll go from there. So that one's at 30 milliamps, and let it warm up for a few minutes. Man, these things are just a pain in the butt to get a screwdriver in. They're so small. I probably would have built it a little differently, but okay, that's about 30 millivolts on that one. Sorry, 30 milliamps. There's 30 on that one, and there's 30 on that one. So we're going to let those sit for a minute and just warm up. That should cause them to actually get some pretty good heat in them. They are. And while that's going on, I'm going to hook up a signal generator and an analyzer and just see what we get, assuming that it actually works. Always good to test. Alright, so what you can't see is my old boat anchor HP 8903 analyzer, which I have something much more modern, but for tube amps I still am rather fond of this thing. So we'll hook that to the left input, and we'll just clip on to the load resistor if I can, without causing any difficulty. Okay. And let's put a 10 millivolt signal in. And that's not what I wanted to see. Maybe I don't have a good connection. No, I hooked it to the other channel. So let's put this on the other one. That's much better. 1 kilohertz output, 0.6 volts. So that's the good part is good. Let's turn the amplitude up to 50 millivolts. 3.4 volts output. I can hear the transformer humming. What's my distortion at that? Which is a little over a watt. It's 1.3%, so I think a little more bias is in order. But the good part is it's working. Let's check the other channel real quick. Pardon my arms in the way. Oh yeah, there's nice heat coming off of this now. So I can get this clipped on here. And change our input over to another jack. Okay, there's our voltage. Distortion. Alright, so both channels are working, so we'll turn the signal generator off. 0 volts. Check our bias. Let's see where we're at here. This one is, so after we turn the other ones up, this one's only at 20 because it, you know, it drew some of the voltage. 24, 28, and 30 because those are the last ones we set. So that would explain why it has such lousy distortion on this channel. So let's turn this up a little bit. Let's go 35. It's pretty close. It's 36. It's going to change a little bit as I turn the others up anyway, but still. Yeah, get in there. Okay, yeah. And our current draw went up. Now we're drawing 1.2 amps at 137 watts because, of course, these are conducting a lot harder now. So now this one's down at 25. Bring him up to 35 or so. That's good. And then this one is at 26. And these a little bit bulbous 6s and 7s make setting the bias a little bit harder. Potential for finger burns, but we don't have to move this thing very much. Okay, that's about 35, 36. It'll drift around a little bit. 34 on that side and 35 on this side, so we'll turn that down just a hair. It's 34.6 or so. 34.8, that's good. 31.4 and 32.9. $34.6. $34.7 and dropped a little bit when I turned that one up, of course. $35.45. Yeah, that's close enough, within half a milliamp. So let that sit for a minute. Now we are drawing 145 watts, 1.33 amps. So it is definitely conducting much more than it was. So now let's turn our signal generator up to 40 millivolts. That's 4.3 volts of output. That seems a little high. Amplitude 25 millivolts. Looking for about 1 watt. So that's 2.6 volts. Amplitude 30 millivolts. Amplitude 27 millivolts. That's close enough. It's 2.9 volts, 8 ohms, so that's about 1 watt. It's 0.73% distortion, which is way better than what it was before, whatever it was, 1.3, 1.7. Let me check, let me change this to the other channel, and we'll measure it. I'm guessing it's going to be much, much happier. If I can get the things clipped on here. I normally use a big load bank and I can just plug into it, but these are just a little test loads, but they're adequate for the power we're putting out. So that didn't work. Okay, put our input signal on the other channel, and our output voltage is 2.87, so it's close enough. Distortion is 0.59%, so it is much, much better. This channel, this was the worst channel. This was like the 1.3% or whatever, 1.7, I forget what it was. Doesn't matter. Anyway, it's much, much better now that it's got a decent amount of bias. He can turn it up to 40 if he wants. Actually, I think for these tubes, 35 milliamps is enough. I don't know what the plate voltage is. To calculate the dissipation, I should measure it. But I think we're pretty good. I think it's about 400 volts on the plates, but I'm not sure. Anyway, we have fixed his bias problem, so that's good. And I think we're going to call it good. I'll hook it up and actually play some music through it just to make sure it works. But for now, we'll just turn off the generator, turn off the power, let it cool down for a few minutes, and we'll take our extension feet off and put all the screws back in. Email my customer, friend. In this case, he's both. So that's about it. Appreciate you watching, and who knows, maybe I'll start making more videos again. I've got a motorcycle project I picked up this weekend, and that might make a fun video. I've put together and worked on motorcycles a lot in my life, but I've never tried to customize one. I picked up an old XS650 Yamaha, 1979. It was a basket case. It's literally, parts of it are in baskets, boxes. It's completely disassembled other than the motor. The previous owner had gone through the engine, put a 750 big bore kit on it, and new rings, new pistons, valve job, all that stuff, new clutch plates. So the motor seems really good. I turned it over. It's got tons of compression, so it feels great. It had cast wheels. And it's got one wire wheel for the rear. I ordered a wire wheel for the front off eBay. It shipped today. It's only $100, not so bad. And a lot of work to do. Probably going to powder coat the frame, but I'm going to put everything together. I've got to make pipes for it. I haven't found any that I like. I have seen some on the internet. Anyway, that is a subject for another video. Anyway, hopefully I'll actually post this. So have a wonderful evening.